In this video, I'm going to show you the process of sorting a character array using the quicksort algorithm. Based on this example, and other examples you will see, you will be able to implement your own version of quicksort in C++. So here we have an array with the characters that spell out the coronavirus sucks. The first step is to create a partition. We are going to go to the first element and the last element in the array, and that's marked by the blue arrow and the red arrow. The green arrow is what we're going to call left. And what's going to happen is we are going to move the green arrow until one of two things happens. Either we cross the right value, or the value is greater than or equal to the partition. So here's what I mean. H is less than T. Therefore, we keep going until we hit a value that is greater than or equal to T. E doesn't meet that, C doesn't, O, R, O, N, A, V does. So what's going to happen is, now we have V, and then we're going to move the right element until we cross the left value, or the value is less than or equal to the partition of T. In this case, S is already there. We know that S is less than T and V is greater than T. So we swap them. So now we're going to keep going until we see this process again. Now we're going to meet until, again, we hit a value that's greater than T. And in this case, U is. Now we're going to move again. K is going to be less than T, so we can swap these again. And then we keep going. S is less, U is greater, and then we have C. We've met the requirement. We swap. And then we move and we finally hit and cross the partition. So here's what we now know at this point. And this is a crucial point, and I will be asking about something like this on your exam. And there will be two questions that you'll have to answer in the coding challenges that will supplement this point. This is where we would start using recursion. We know at the partition stage before we recurse that all the values to the right are greater than the partition. We also know that all of these values are less than the partition. So now what we can do is we know that C will be less than T, so therefore we swap these values. This is going to be the solution to your exam questions. What is the status of the partition of quicksort in the first operation? We now know that all the elements to the right of the right element, noted in the red arrow, are greater than that element, and all the elements to the left of the element pointed to by the red arrow are less than it. So again, this is what I would ask for on the exam and in the two coding problems. So now we're going to perform recursion, where we recursively sort the left partition of the array, then we recursively sort the right. So now what we're going to do is we're going to go through the whole process and you're going to see the whole sort. So what's going to happen is we have characters 0 through 18, since the coronavirus sucks has 19 characters. 16 through 18 are over here on the right. 0 through 15 are over here on the left. So the left recursive call is going to go and take these values out, and now we have the first element and second element. So let's walk through this process again. We're going to move the green arrow until we hit a value that's greater than C, which we're already at. Now we're going to move the right arrow until we hit a value that's less than C. And we're going to encounter this at A. And then we swap. Now we're going to keep going, greater than C. Again, we hit it at E, less than C. We're not going to find it. I'm sorry, I apologize. There we go. C is equal, so therefore we swap. And then we exchange. We now know the new place that we should go. So what's going to happen is everything to the left of the arrow is now less than E, and everything to the right of the arrow is now greater than E. And so now we have 0, 1, and 2 that are going to sort C, A, and C, and then 3 through 15 are going to be on the right hand. So again, we go left, we perform this operation, we actually can change it, and now we swap A and C, and now we see that A, C, and C are properly sorted. We go back up on the recursive trace, and then we go back down through 3 and through 15, which is what we passed right. We perform the same task. O is greater than E, and so now we are going to look for a value that's less than E. And we see that it gets all the way here. Now we can swap. We see that E and O are the same, so now we're going to do 3 and 3 to the left because E is by itself. We were able to get all the way through without finding anything less than E. So we recurse back up. We now have 4 and 15. R is greater than O, so now we have to find something that's less than O. And we see that we're going to be able to do this when we hit K. We are now going to swap R and K. Now we do the same thing. We hit O again. And now we're going to go and find something that is less than O. And what's going to happen is we hit I, and now we're going to swap O and I. We're going to do the same process here. There we go. And this is a crucial point. S and O were out of order, but now because we've done it this way, we can swap them, and now we're starting to see that things are going to work. And now we hit that partition, and now we have 4 and 15. We can split it up with 3 and 9 and 10 and 15. When we go left, now we're going to take care of O. K is less than O. And then we just find something. I is less than O. N, H, and then we hit here without finding anything greater than O. And so now we can actually just swap those values. And this means that we can say that we have H and K. We now recursively call 3 and 7. We do the same process. 3 and 3, 4 and 7. Now we can go back up, and now we're at 10 and 15. So before here, 8 and 9, that's fine. For simplicity, we're going to skip over to the 10 and 15 portion. So let me draw that out. I wanted to save some time animation. We go here, 8 and 9 are already in the correct order. We go up to 4 and 15, and now we're going this way. So that saves some steps in this little video. So we're up here, and now we're going to do this portion. Now we can say, well, R, S is the same. We get here S and S. We swap them, and it turns out it's fine, but the benefit of this is that we get our next partition. 10 and 13, now we can get the R's to the left side of the S. There we go. Now we have our swap. And so now we have everything in order. Everything else would go through, make the comparisons, and just not swap because we would just hit our partitions. The benefit of this approach compared to merge sort is that the work is done before the recursive call, so it is faster than the merge sort you learned in Fundamentals of Computing. And it saves several unnecessary calls. So here is the sorted quick sort value.